Hey Matt, how you doing?
How's it going?
We are in a brand new world here. We are
I
streaming
know,
live
I
theoretically.
know. It's terrifying, isn't it? I'm pressing a million and one buttons at the moment, and I'm trying to make sure I'm not missing anything. I feel like I'm gonna send a shuttle to the moon.
Well, it is a bit like that, right? That's the thing with doing a live broadcast here. It's like we're almost have our own little TV show.
I know, right? And that's what's really exciting about it. Really, really exciting.
So, what do you want to talk to about today?
So, if you remember on the last one that we'd done
Yeah,
when we're talking about construction stuff is still going on, by the way. having
absolutely.
this con- Having this conversation and going on further and further about construction and some of the stuff that the guys deal with, when it comes to chemicals and cleaning exos, and it just goes on and on and on. But
Right.
anyway,
But we
there's a
were
couple of
talking about
bits.
like prosthesis and orthotics and materials and all that stuff too. How does that tie in together with that?
So for me, I'm going to open up. I'm going to open up my favorite topic that everybody goes, "Oh, why does he not get this?" Okay, what exactly is when we refer to an exo? How are we referring to it? Because a lot of people are throwing prosthesis into it.
Okay.
They're throwing, and you see, for me, an exo offers that assistance, that support mechanism around it. It's God forbid, it's almost like an assisted brace, but
O-
it's not quite an assisted brace. But a prosthesis is a replacement of a limb, and I'm still not clear about.
Okay. Let's do this. So I have the appropriate background because we're going to take a an Avengers theme to my example here. So we have our favorite and non-favorite Avenger, the infamous Iron Man, which everybody says that's an exoskeleton. And then we have the sort of Avenger who appears in a lot of episodes, who's Captain America's best friend, who's Bucky. And he
Okay,
has
yeah, the
a
Winter Soldier
prosthetic arm
down. That's right.
that some people would say that's an exoskeleton. So,
Yeah,
where do
and
we sit with this?
mm-hmm, mm-hmm. So now this is where my grumble, because I always have a grumble. This is
Yes.
where my grumble comes in. So we refer to an exoskeleton. It's a wearable device around the body that offers assistance. I mean, I can pull the term, and
Right.
we've heard the term in the other podcasts. But when we then look at it, you kind of go, well, it's a in that much respect, it's an arm that's attached to the body. Is it not supernumerary, if anything?
Sure. Sure. If you can you if you have an exoskeleton that is a secondary, tertiary, whatever you want to call arm, is supernumerary, yeah. And but here's the thing. The prosthetic, one of the intentions of that is a initial intention is restoration of some function of a missing limb, right?
Hmm, hmm.
even
Yep.
even if we're in the Bucky, sci-fi case of hey, it's better than his original arm probably. So even in that case, it's still a replacement of what was originally there. Could that also be called an exoskeleton? I guess is really the question here, because if you read the definition of exoskeleton, which we've read probably way too many times for
Hmm,
an
hmm.
adult, um, yeah, I would say, you could make an argument that you could call that prosthesis an exoskeleton. It is a wearable device that it has mechanical interaction, and it provides some sort of benefit to the user, right?
Right, right. Okay, I could get to that position. But then I'd argue,
Yes, please do.
is our definition of exoskeleton then a little bit too broad?
Ah,
Do we then incorporate too much within that term of the exoskeleton?
right. And that might be the rub in this, is that while yes, you could fit that prosthetic in the exoskeleton, that's not what the intention of that device was initially. It was not intended to be this exoskeleton that would um, originally amplify, like we talk about in the Hardiman, man
Hmm.
amplifier type thing.
Yeah,
It was
yeah.
not originally designed for that. It was designed to be a medical device to restore function to a missing limb. That's not really in our current definition, even though you could fit this device in our definition because it is fairly broad.
Yeah, because I mean the term, our term at present sits as wearable device that augments, enables, assists, or enhances physical activity through mechanical interaction of the human body.
Right, right. And that goes back to our original thing, which is you could fit a lot of things in there, but that doesn't mean that's what they are. And when it all comes down to it, it's like, is that a real issue? Because like we were talking about last time, like one of the bigger issues that we're dealing with is like, okay, how does this help us push forward with things like compatibility between the exo and the person? How well does it fit? How well does it function?
Hmm.
What does it change as far as the risk profile? We were talking a lot last time about how does it change your center of gravity. I think
Yeah,
I
yeah,
think
exactly.
those are key things. Yes, we could mess with and fidget with the terminology definition a lot, but does that help us in these other areas that are very functional? Is my argument in this area.
Okay, yeah. I mean that makes sense. That makes sense. But I mean, it still puts it out there for me if it's just it becomes too cloudy. But I think you're right. I think
Yeah.
why try and make it just because that kind of falls into that area? Why should it have to be within that area? The only thing that and there's always something. The only thing that I'd ever leave me on that curious side is when you get to the position of liability,
Right.
when
Right.
you start to refer to things. If this puts that realm of where people can, like a better words, because let's face it, some people do bend the rule of what it is that they're trying to do,
Right.
and they endanger themselves in that process. If we don't define it, and somebody says, "Well, I don't know, I thought I bought an exoskeleton when it was a prosthesis," or something like that, is that going to put some companies in muddy water?
Yes. Yeah. And that is part of the reason why I'm somewhat playing the devil's advocate and I'm kind of pushing back on all this. I'm kind of on your side in that I think there needs to be some clarity, and it touches a lot of areas as far as liability, but it also helps. One of the things we talk about a lot. Me and Matt work in standards a lot, and one of the things we talk about is making sure people understand what standards apply to their device. And right now, in the exoskeleton world, there's a lot of dependency on what is the intent of the manufacturer or inventor of the device versus being able to go to the definition saying that is for sure an exoskeleton.
Yeah. Yeah. There's so many unknowns, isn't there? That
Right.
actually sits within it.
Right.
I think that moves nicely into an area of that we were starting to dress around on the former podcast, which was materials,
Yeah.
and when we refer to materials and what's a good material to be used and what's not a good material to be used, and when you're considering it. So, for example, let's say you want to load up somebody to death in different materials. As the structure gets heavier and heavier, they
Right.
need actuation. The body's never going to support that level of thing. But if you get to a position where there's so much that they're wearing, when do they actually start wearing a vehicle? Because I
Ah.
mean, you look at the term vehicle, and then some would say, well, GE came up with Hardiman and they started coining the term exoskeleton more formally. In fact, in the Guinness Book of World Records, they're down as the first inventor for the powered exoskeleton,
Right.
not passive, but powered.
Right.
However, they also had the walking truck, which
Yes.
they coined a vehicle.
Yes.
So you kind of go, it's the same principle. When does that water change again?
Yes. And it's funny. It's like that was some of the initial conversations, the very first conversations when the committee F48, that's the committee on exoskeletons and exosuit was formed, was. And one of the things I remember people talking about very intensely in the room was, if you can ride in it, it's not an exoskeleton. And that was kind of the sentiment. This is back in 2017 timeframe. Is that they did not feel like, if it's a, like, again, back to the movie analogy, if it's the power loader from Aliens,
Mhm.
you're just riding in it. You're not really wearing the exoskeleton. And that one, that one's sort of on the edge there. People could make the arguments, well, you have to
Yeah,
move
yeah.
things around, and maybe you're not riding in it. That was a lot. We use the movie analogies because people can kind of see that in their head, but that is a big thing. What's the difference between an exoskeleton, the way we have it defined, and a automated driving vehicle? Uh,
Yeah.
you know,
Like a
you
Tesla.
like a Tesla. That
Mm.
could be. That's kind of what we're trying to do, is figure out how to sort different things into their different perspectives, and that's the same thing with materials. Me and Matt were talking a little bit before we got on about, we have some words like biocompatibility uh, that have some medical type meaning when you're talking about things, devices that are implanted in the body and all that. But we don't have, perhaps, I'd say, more widely used terms about what's the compatibility between a material that you're wearing over your body, especially around like mechanical strength and how it changes things for whether it's on your arm or your leg or stuff like that. The closest thing I've ever heard is like, you talk about this term where if you had you had a medical condition, you had to wear some sort of fixation device over a bone that was broken, and they talk about this idea of stress shielding. You don't want the fixation device to be so strong that your bones can't heal back and grow.
Mm.
And so, but with the exoskeleton, you're sort of in that same thing. It's like you want to have some compatibility between the person and the device in the right direction, and you want it to fit well. Does that make
Mm.
sense, Matt? You see what you
Yeah,
hear?
yeah. Yeah, no, that makes sense. That makes sense. So, I mean, for clarity as well, wait, stress shielding, how I understand it, is the bone itself needs to be under some level of force, doesn't it?
Yes.
And it needs to almost crack and then kind of grow together in that stressed process.
Right.
So, because the big concern is also with astronauts, isn't it? The same
Yeah.
principle of that the bones are unable to do so, and that's what a system. If it was too good, it'd be keeping that from occurring. That's correct, is that not?
Yeah. So this is actually an area I did my dissertation research in. So I'm gonna be a bit geeky, but very slightly geeky. So
Yeah.
there's two main cells. There's the osteoblast, B for build, and the osteoclast, C for cut. They're both very important for bone health. They're both working it all the time. You got a little bit of cutting away, got a little bit of building going on. That's what keeps your bones healthy and keeps your bone density. When you get an imbalance of those things in a very bad direction, you get into real trouble. You get into osteopenia, osteoporosis, blah blah blah. All these things that can go wrong. Uh, so astronauts, people, you got to think of a bone sort of like, in a weird way, sort of like a sponge. Yeah, it's hard on the outside, but it's a sponge on the inside. And what's happening is, whenever you're walking, moving, doing whatever, it's tweaking slightly. So a little bit of bend.
Yeah.
And what's the other thing is, and this is the key thing, this is how it touches the astronaut. This is what I'm driving to. It makes the fluid, because it's filled with a lot of fluid, blood, and a lot of other stuff, it makes it move. And so one of the things that in my research and other people's research, they found is fluid flow is one of the stimulators for those osteoblast, and probably osteoclast too, but definitely the osteoblast. And that was one of the things that is an issue when you're an astronaut or you're in space. Fluid doesn't move the same way. There's lots of great, cool videos about how fluids move a lot different in
Yeah.
space. And so that's one of the challenges when you're in space, is that the fluid in your body isn't moving exactly the same way. And you can't put, because you don't have gravity, you can't put the same kind of stresses on your bones, which they need, you know?
Yeah, yeah,
So
which makes sense.
anyway, that's kind of like,
No. I mean, it's always nice to talk that out a little bit, just because for the benefit of anybody who's listening to this, but also myself, just because I have an appreciation of it, but nothing to that degree, and to get that breakdown is really good.
but it's very similar with, an exoskeleton. Especially if you go into, which a lot of exoskeletons are, is what we call passive. So they don't have a battery or electrical, pneumatic, whatever type system. They need stress, stretching, whatever it may be, to actually work. They're very similar in that perspective as to bone and tissue, is that they need some level of stress applied to them to cause them to function properly. And so that there is some comparability, and that's part of that thing where you see you don't have. I haven't heard anybody say this, so this is going to be a wild kind of accusation or statement out there. Is that I haven't heard anybody have any concern about really the compatibility between a passive exoskeleton versus that compatibility with an active exoskeleton, where it could be outpowering the body or any of that kind of stuff. And I think
Yeah.
it's because of this whole concept of this stress shielding that is what I'm driving back to, is those things are all connected in a way.
Yeah, I can understand that. I mean, that moves even further down the lines, right? So we know that the way that they're designed, they have to be designed a key particular way where the body can still do away with any types of stress shielding. We know that they need to be able to withstand a certain level of condition. But
Right.
when you talk about materials and that overall material operation,
Yes.
there's multiple boundaries that we hit here, isn't there? I mean,
Right.
how do you keep costs low? I mean, obviously,
Right.
when you're talking about manufacturing anything now, it's all about carbon footprint.
Yep.
Are you damaging the environment by doing key things that you're doing? And if you're mass producing on something that's churning out very dangerous or very bad things for the environment, it's not really it's not a sustainable system that you're going to go at. So it poses then a lot of concern and questions as to how do we progress.
Yeah, and the part of it also is, and I'll tie it back into like some simple things, is that how long are you going to wear the exoskeleton? Because a lot of things that may be concerns, even the stress shielding concept that I'm talking about, not a big deal if you're not wearing an exoskeleton 24/7. You know, uh,
True.
Same thing with your manufacturability. How long is the device going to last? My argument would be this, is that the longer the device lasts, probably the less impact you're going to have on any environmental thing. Even if, think of it this way, we make this trade-off all the time with cars that have hybrid cars or electric cars. They have giant lithium batteries in them. We're making that trade-off every day about this. How long is it worth the things we do in order to get the benefit? And so you have to go through that process with all of these things.
Yeah, is the juice worth the squeeze?
Yes, exactly. Exactly.
Yeah, it's a good point,
Yeah,
and
and
it's go ahead.
no, I was just going to say, and it's all about generation of power, and that is a key thing in all our kind of exoskeleton stuff. It's like, we talk about, it's like, okay, where's the power going to come from? Is it from, one of the things in passive, most of the power is coming from a material type element, some sort of inherent stretch or whatever it may be of the material. With a powered system, is coming through some sort of either electrical or pneumatic type device, where you're getting power from the outside in a sense, and it's being generated somewhere else and it's coming in.
I mean, I must admit, one of the biggest, I mean, just a side note to this, one of the biggest interests from my side is typically every time we've been in a room and we've listened to people talk about what's needed when we refer to an exo, right from some of the places where we've been, where some had sat there and said, it always needs to be grounded.
Right.
There's only so far you can do things with elastics or with bands, and you kind of go, right, okay, I understand that. But then you look at some of the new ones and they defy that. So, for example, the hypershell.
Sure.
So the hypershell is an interesting one for me. I'm still obviously on the fence with it. I'm always going to be skeptic until I can say 100% it's going to save me. Right now, I'm kind of like that. I trust you guys for the minute. I'm kidding.
Yeah.
But what's interesting for the hypershell is they've come at an approach where they have an active system which isn't grounded,
Right.
and it's looking at an assistance around the hip.
Right.
So it's not really. I mean, there's a lot of discussion. I've listened to a lot of discussion about the way that it's translating that force. You know, if you're moving it away from that hip, does it all get dissipated across that bone? That, I call it a bone, component or a limb.
Same thing.
Does it get entirely dissipated across that, or does it not?
Yeah.
And that gets me onto a bigger question of that. If you've got that, you've got many others, and then you get to the point of that. If you're using these materials, is anybody testing to make sure that these materials are going to be sound for this key particular role?
Right.
Don't get me wrong, there are some companies out there. I mean, I know because I've chatted with them, who have generated these exos, and they have done some tests, and it's great. But they've actually, if you will, over-engineered to ensure that safety level.
Sure.
But some, I've actually sat with them and said, "Are you sure?" And they'll go, "Oh yeah," and you kind of go, "I'm not convinced."
Well, it's very true. I mean, that is part of, I would say, the engineering cycle. Your first temptation is to over engineer, and for the folks out there, like, I'll give you a couple things. One, I'll rewind just a second because Matt said grounded, and maybe if you're not in the exo area, you don't know what he means by grounded. So when we say grounded, that means that there's some like physical element that actually goes to the literal ground that's transferred, and the load is transferred instead of being on the person's body onto the ground. So just for clarification, not the electrical side of grounded. That's a different kind of grounded. And then, this idea of kind of how do you take something like any of these devices and figure out where does the forces go, and is it done in a way that's going to be effective, and how do you measure that? And the over engineering, when we say that, what we're kind of talking about is factor of safety. That is the engineering term. So it means is if this is going to break, if this pen's going to break at 100 pounds, I'm going to give it a factor of safety too. So I'm going to design it so it won't break unless it hits 200 pounds. So simple stuff like that. But that's what we're kind of saying when we say over engineering. It's like, hey, I'm kind of concerned, so I'm going to give it this kind of factor of safety.
That's right,
and go a little bit beyond of what is supposed to be worked at.
That's right. Yeah. I mean, this is not to bash anybody in this. However, I was doing some homework on another one. Really, really interesting, right? So I'll paint the picture. Somebody gives me, let's call this an ear lashing. Somebody really lays into me on a meeting one day, telling me about a new device, how it's been tested, and I'm like, okay. Don't shoot the messenger. I then come off, and then I spend the following day looking into this device. So this device looks sound, really, really reliable, very impressive. Then when I looked a little further, it had gone through cycling.
Yeah.
And true, it had been cycled. And I'm like, that's amazing.
Right.
Then I looked at the maximum force cycles it was put under.
Right.
5 newtons.
Woo!
and you go, I can probably, it's basically something like that.
Yeah,
So
yeah.
it's basically, as long as nobody strokes your hand, you'll be okay in it.
Right,
But
right.
my point is this long, elaborate design review was given in it, and it does look extremely impressive. And then you look deep and you realize the force data that's put into it is not much at all. It's
Right.
next to none.
Yeah, it's basically a movie set. You know, it's like it looks good, seems great, but there's nothing behind it. It's gonna fall over. It's propped up. You know,
Yeah, yeah,
and yeah,
yeah, yeah.
and
Exactly.
that is a concern. That's one of our concerns for any type of device, whether it's an exoskeleton or not. It's like okay, has it really been tested? Has it been tested appropriately? And can we rely on what we're being told? It's all about trust at the end of the day.
It really is, and I mean that's what leads it, isn't it? To that, I think that's what led it to that point of adoption.
Yes.
I mean, I'm going to say a really controversial term. You may or may not agree with me.
Okay.
My experience in the past 12 months of exoskeletons on soldiers
Mm.
is probably no. I'm not convinced. I mean, I've spoken to some soldiers, and they are absolutely phenomenal human beings.
Right.
And you know, when you think, I actually think I'm going to slow you down if you put my stuff on.
Yeah.
You know, so I mean, for the future maybe, but I think right now, I think a lot of people have really, once you start to lean onto construction, you lean onto consumer,
Right.
then we start to see the big bucks and where it really lies. And then when we get these control systems working nicely, then onto rehabilitation, but really hardcore rehabilitation, I think that's where it really lies
Yeah.
into that key particular case. But we can test it. So let's say, for argument's sake, we've now got an exoskeleton, we've tested it mechanically. We know before somebody puts it on, it's mechanically sound, it's safe.
Right.
To a degree. I mean, we can never say 100% if you put this on, you won't, I don't know, pull a muscle. It may, you may be just that unfortunate one that gets that.
That could happen without it.
Yeah, exactly. And I mean, yeah, exactly. I mean, how many times? I mean, I've lifted all sorts in my life, and then one day I went to lift a plant pot,
Yes,
about
that'll do
this
it.
big,
Yeah.
and then just that pop. You know that little pop,
Oh
a
yeah.
little warm pop in your back, and you think, oh, that's nice.
Yeah.
And 20 minutes later, it's like agony.
Yep. You're flat on
So
your
yeah.
back. You're done.
Yeah, exactly, exactly. So we kind of get on that particular point of that. If we can test it and we've got that mechanics of it, we can, we can know. Let's, in this case, let's say we're happy with that and that will work within it. The next phase of this, fitting.
Yeah.
So I got a nice one on this one. This week at another ASTM meeting, I was sitting in with the textiles, listening to some of the big bods from all over in textiles, right from sports gear, right from across all different areas, and they were talking about fit,
Mm.
and they were talking about body shapes and all different types of things like that. And they've done over 100, I think it's 120-year-old
Yeah, it's a very old
committee.
committee. Yeah.
They've been around for a while, and even they were saying that there's still elements of body fit that doesn't quite work for what they're doing.
Yeah.
They
Yeah.
still can't capture key elements about the human body. And I mean, that was just one particular gender. But I mean, capturing all genders, all areas all over the world, different ages, you kind of look and go, there's billions of possible combinations. But that's really interesting, because if we pan this back to the original conversation of prosthesis, and then on to exos,
Yeah.
how would you ever really get that fit perfect?
Right. Well,
Really ever get it?
it does make me want to use, one of my favorite British terms. And I don't have a lot, I do like mushy peas, just
Mushy
for
peas are the best.
just for the record. They are
Yep.
good. But one of my favorite words is bespoke. And it's been around for probably hundreds of years. And that's how suits you used to wear to go into the office back in the day. That's how all of them were made originally. That's how even shoes were made originally. They were all bespoke, all
Yep.
custom, all fitted to the person. And there's probably a good sector of the exoskeleton world that probably needs to be bespoke. I mean, it's not back to our original. We're circling back here.
Oh yeah, but this is nice because we
Back
kind of
to
compliment. Yeah,
back
yeah.
to prosthetics. It's not all the prosthetics for the most part bespoke, especially those that are fitted to limbs that are still remaining and stuff like that.
Hmm. And I mean, I've got to pay homage to one of my personal nerdy heroes in this case, is Hugh Herr. I
Yeah.
love Hugh Herr. I watch all the talks he's ever done. Just a bit of a nerd in that side. But if you've ever seen this, Hugh made a system where he placed where his lower limb is a double amputee for anybody who
Right.
doesn't know, but it's Hugh Herr, but it's a double amputee who's lost both legs above the knee. And I think, as far as I understand, it was from climbing accidents.
Yep.
But anyway,
He was, I believe, it was ice climbing or something. Or he
Yeah,
does ice
yeah.
climbing still, I think.
And yeah, I mean, that's what I mean. When you kind of go just above and beyond me.
Yeah,
I'll just look and go, that's brilliant.
Yeah.
So what he did is he in trying to counter that process to get the best fit for his legs, he actually made a device where it places both of the lower limb, if you will, stump areas,
Yep.
and places it into the machine and brings in not potentiometers. I forgot what the device is called that comes in and measures the distance.
Oh, it's like a caliper, basically.
Yeah. But basically, it's a chamber that's got a ring of them on it, and it will
Ah.
come in and close around the leg, and it's to capture that bespoke measurement every
Wow.
single time to ensure the fitting for the legs. Now, you remember the Boston bombings?
Yeah.
I think everybody does. On the Boston bombings, one of the runners on there was a famous runner, and she, apologies, a famous dancer, and she lost one of her legs. And Hugh did a leg for her. So if you ever get to see a TED talk on that, he built a leg for her, and then she comes on dancing with this leg. And honestly,
Wow.
it's just something else
That's
to
amazing.
see. But that just shows the importance of fit.
Yes.
So when we get back to the bespoke element of it, let's face it, because you're right. I mean, the best term, in fact, you coined this term to me years ago. Savile Row of exoskeletons.
Yes. Yeah. 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 An exo tailor kind of person. Yes.
It really is, isn't it?
Yeah.
I mean, if I'm honest, if I think I'd heard this originally on yours and Nora's
Yeah.
excellent exo chat,
Yep.
when you talked about the excellent tailors, where you
Yeah.
go in there and you're fitted for your exo to fit and suit.
Yeah. And in some applications, that is, I think, the appropriate way to go. And that is a key thing about fit. And I'm gonna widen the perspective on fit, because I'm gonna circle back to one of the things you said before. Also, is trying to, one of the things I've said many times, trying to peanut butter spread exoskeletons is not a good idea. It doesn't fit everywhere. And that's been one of the things that's been a challenge, especially in the military environment. But you could say the occupational environment. You could pick one. Is trying to peanut butter spread it where everybody gets exoskeleton. You get exoskeleton. You get exoskeleton. No, it makes, at this point where things are, it makes about as much sense as giving every person in the military snow skis. I'm like, okay. I don't care if they're the best snow skis in the world. I'm not going where there's any snow. It's kind of that way. And so fit to me is also about not just a fit on the person, it has to fit the application too. And I think that's the part that sometimes people get a little bit, over their skis on that a bit.
Yeah, exactly. I see this moves quite nicely into one of the conversations that occurs in 48, in particular O2, and that's led by one of the subcommittee chair, Tan, and him and a few of the developers in there. They've often talked about the idea if you can achieve that fit, but once you achieve that fit, depending on how your gait is executing, your pressure contact of that fit could influence your body's interface against the exo as it's moving.
Right.
So, and we know this. I mean, everybody who's developed a prosthetic, anybody who's seen that human to machine interface will know of contact sores.
Right. Right. Yeah.
And they'll know of that major issue on contact sores. They'll know of them key things. So it does really open up a lot of questions when it refers to fit in that case.
Yeah. And, it's funny. So, one of the, I'll call him a legend because he'll love that. One of the legends of F-48 and exoskeleton world is Roger Bosselman. He's retired from NIST, and he and I were talking years ago, way before there was a F-48 committee. We were talking about this issue of how do you measure whether you've got not just a good fit of the exoskeleton, but if the exoskeleton maybe is too tight, you're getting bruising, or you might get a friction burn, or you might even get something more than that. How do you make sure it's secured on the body in the right way, and it's not too much and it's not too little? And how do NIST is the nation's metrology institute, and so we were thinking, how do you measure that? How can we use something like ultrasound or some other way to non-invasively measure people so we know how to fit it good? And it ties in very well with the prosthetics. They're doing that all the time. They don't want a pressure sore. They don't want any of this. You're wearing it, for many hours of the day, if not, 24 hours a day, maybe in some cases.
So, I mean, there's a few things with that. So, one of the companies I've spoken to who over-engineered their exoskeletons, I should say over. It makes it sound like it's something that's big. It's not like that. It's they've ensured the longevity of the components will out. I mean, some of these exos would outlive you.
Right.
They are that engineered to such a reliable aspect. But what they'd talked about is they'd come across with the same thing. So what they were using and still use is rash shirts that surfers use.
Yeah.
Rash shirts. They recommend rash shirts just for that key particular reason of where.
Yeah,
exactly. If somebody's wearing it for a certain amount of time, you'll end up with contact sores around these key areas, and it's hell you can get it from wearing a hat, but the issue is obviously if you're wearing something like that, you need to be able to don on, don off comfortably and not end up with too much biotransfer, let's say.
Yeah. Well, and now you've used the word over-engineered several times. I have to go back to our movie analogy. When the first infamous Iron Man movie came out, he over-engineered the first Iron Man suit. It was a giant hunk of junk that shot out of the cave and crashed in the desert. He escaped.
Yeah.
But compared to next generation type suits, after he actually did some more thought and more tinkering, that one was very crude and way over engineered. And so it's like, what I'm saying is that's part of the engineering cycle. This is how we all start. I'm sure that was probably some of the reasons why when people were trying to design airplanes, that was probably some of the reasons why some of the initial ones didn't fly. They were probably over-engineered. They were too heavy, but they were safe.
Very true. Very true. And that moves on quite nicely onto my next. Well, I mean, I know I won't take us too deep, or else we'll be on this forever.
Yeah, because we're going to stop at 1 hour for sure.
We're going to have to stop at some point. And this complements some of the stuff that our friend Adam is doing. So, let's say now we've certified that design. We've got it tested, and we know what it does. We're happy with that. Now what we've done is we've made sure it fits, and we made sure that if somebody takes it on and takes it off every 5 hours, you shouldn't be getting contact sores. It should be fine.
Yeah.
So we've got that nailed down. Now, how do you know it's doing anything of any use? And how do you know that you're not looking awesome for cosplay?
Yeah, and that is a real issue. So as you know, we ran the Exo Games for several years, and there's a new one coming up here in August. And one of the concerns everybody had when we had students building exos and doing all these contests, it's like, how do we know if it's actually working? How do we know if it's the exo doing the work or if it's just a student who's really fit? Now,
Because that's what happened. Uh,
okay, yes.
yeah, yeah.
Maybe. I don't know. I
Yeah,
don't
who
want to
knows?
know.
Yeah.
But the thing is, it's like, if you're the one spending the money, I'll just be very simple. If you're spending the money and you put on EXO and you can't tell it's working and it's not providing you any benefit, you know right away without any kind of fancy testing. But how do you know before someone spends the money on it? That's kind of the rub there to me.
So yeah, I mean, because I mean, we're making it a bit sound like the Wild Wild West at that side. Let me just bring it home a little bit.
I don't think it's Wild Wild West because I've had exos on that. I know they work. I can feel it.
Yeah. I mean, but my point is, I think in that side, the theory can always be sound.
Yes.
So companies can say, look, the theory's sound. It should do ABC. It should do ABC, and then somebody puts it on and then goes, no, it's done A and B, but not quite C.
Yeah.
So right now, I mean, establishing that baseline,
Yeah.
that minimum criteria, that minimum specification that an Excel's got to achieve to be within that certified level.
Yeah.
I think surely that's where it's really going to have to move towards, because don't get me wrong, the technology and some of the developments that's out there in Exos is amazing. However, without that testing, now that certification piece, where do we really sit right now? As a friend, as one of our friends said recently, our standards are fantastic, but they're not worth anything if you can't specify.
Yes. Exactly. And it all comes down to back to what we sort of talked about a few times throughout the thing. It's about trust, and this is a way to establish trust. Is having a measurement system that everybody can use. Everybody has agreement that yes, this will show one way or another that it actually does something, and you have independent labs that know how to do these kind of tests, and anybody can go to them and get their stuff tested. And it's like there is no more question about whether, okay, did somebody did the test, but they used it at like a fraction of the force that you should have done it at, or they did half the number of cycles, or they did stuff that worked to the advantage of their machine and would have never passed any other test. All the crazy kind of arguments that are out there. It takes all that noise away.
Yeah. I mean, I understand that. Yeah, 100% understand. I mean, it really falls also on that manufacturing side as well.
Sure.
Of that when you're referring to these things, when you're manufacturing, how do you keep costs low, but how do you also make sure that you're not making costs low enough where you're compromising the actual design and it becomes unsafe in that process?
Well,
because this is why you got to test against it.
Yeah. Well, here's the other thing. This has been one of the challenges. Is this is a good and a not so good thing? The exoskeleton research and design world is moving super fast. There's amazing things happening every day. And the problem is amazing things are happening every day, which means your design keeps evolving. And there's no way in some respect, if your design's always evolving, you have to lock it down at some point so you can manufacture to that design. If you don't have a way to make sure through testing and certifications, hey, I know this design's good. We got this result. It's independent. We know we got good stuff here.
Yeah,
we can at least lock down here, build this while we're doing this stuff in the background. And we know we have something solid to build off of. That's one of the things I see as exciting from a manufacturing side is I know I can test different designs and know this for sure is making a difference. And if I do a new design, and I test it, and it comes out the same, or maybe not as good. Okay, let's not go that way. Let's stick with what works.
Yeah, that makes sense. Yeah, because I mean, it's it's just really interesting. It's just thrown me on a bit of a back burner there. I was just lost my train of thought.
Oh, it's okay. See, Matt makes exoskeletons, so I'm making him think really hard here about, oh my God, did I do that?
Well, it's interesting just because we talked all the way through about the manufacturing side, we talked about that safety side, and then we talked about the fit side.
Yeah.
And like you said, intent. How long is it going to be used for, and how long is it going to be how long is it going to be worn? And through looking at the moment, some of the bigger predicted areas of usage for exoskeletons being used on a large scale is
Yeah.
consumer.
Yeah. Yeah. And
And
there's a huge market there too.
so, I mean, if you think about, in the UK, they call it healthy living,
Yeah.
healthy aging, they
Oh,
actually call
nice.
it.
I like it.
And with healthy aging, it's about keeping the older generation more active, keeping them strong and moving. Because there's a lot of research that suggests if people don't become recluses and they get moving, they'll have less need for healthcare, and they'll
Right.
always be, if you will, moving forwards. So the idea of that means that if we're designing exos to go into people to help them go hiking, for example, it means they're going to be wearing these 8 to 9 hour bursts
Yeah.
because they're going to be hiking.
Yeah.
They're
Well,
going to be walking all over.
there's a lot of truth to movement is life, and one of the reasons I got in the exoskeleton area was because of my mother-in-law. Her knees. She couldn't get up and down steps and had trouble getting up, off a chair or a couch or anything like that. And she wanted to. She was super excited about her brand new grandson and all that, and she wanted to do all this stuff, but her knees were kind of holding her back. And there's a lot of people in that situation where, they want to do these things, and it's just all they need is one little simple aid, and it changes their entire life. It
Mhm.
brings a more full life to them. And I think that's one of the promises of exoskeletons is it can bring a fuller, richer life to people for regular living, for work, for whatever you're doing. But it's got to be applied, obviously in the right way. That's
Yeah,
all there is to it.
yeah. I mean, for me, exos have got to remain safe. They've got to remain reliable to what they're going to deliver. They've got to support what it is that you want. But I think in some cases, I think some companies need to keep their eye out on what it is that they're doing. I
Mm,
think some companies are doing an amazing job, and I think it's an interesting area of where what we're doing and what everybody's doing on the committee at the minute is really trying to set that standard to aid in adoption.
right, right.
And I think that's what will bring us to that big important time of adoption. Because at the minute, who knows, you know?
Well, and you know how I like looking forward a lot. I still think one of the big promises in exos, beyond the things we've discussed, is in the I'm gonna call it the space industry. I think as we move toward doing stuff on the moon and eventually on Mars, there's going to be a greater need for these
Yeah.
types of devices. Just the things we were talking about with astronauts, uh, with bone health and all this. There's going to be a lot of things that are going to need to be addressed, and exos might be one of those solutions that's going to help address those things and help people be able to function fully in
Mm.
a moon or Mars type environment. So
Yeah.
I think
Yeah.
there's a lot of promise for this technology. I think there's a lot of amazing things going on right now, but it's we're still in, it's like you say, we're still a little bit in the early days.
Yeah. Yeah. Exactly. We're still in that position of where, well, they call it an emerging technology.
Yeah.
Interestingly, AM 3D printing is moving away from becoming an emerging technology and
Yeah.
becoming an adopted technology.
Right.
Don't get me wrong, that's got its skeletons. We all know about them. But that's the point of that. If you follow the trend lines of how AM's taken up and how that's gone, that's really what we want for Exos. The same process of people seeing that reliability, picking them up and using them for
Yeah.
their purpose.
Right, right. Yeah, and I think, the accessibility to exo technology has to evolve to the same level as you see in the, 3D printing type technology where, almost anybody now can buy off of Amazon or anything a 3D printer and try stuff out at their home.
Yeah, yeah, exactly. And I think, and moving forwards for our podcast, for example, I'd like to. I'm going to be trying to reach out to bring in some guests as well that would who've either used exos or see a potential for exos, because I'd like to get their take.
Yeah,
Because for us, we come at it from our perspective of consultancy and manufacturing,
right.
and it'd be nice to start seeing from the other side of the actual scale of people that we know right through military, right through to working in construction, and let's see what they say about it too.
Exactly. Because in some respects the customer's always right and you really have to focus on meeting a need for the eventual customer, not just, we can make whatever we think is cool, but if it doesn't meet a need, what's the use in it? And I
Yeah,
think having people come on and say, hey, here's where I could really use this. I mean, that's been one of the challenges, we've seen over and over again in the adoption in the, I'll say, the worker occupational type sector. If you put an exo on, I'd say, what I would call now the younger kids that are very healthy, they're like, I don't need this.
yeah.
You put it on somebody closer to my age, I'm like, oh yeah, I'm wearing this. This is, my back's already sore before I even got started. Put this thing on me. If it's gonna keep my back okay all day, yes, come on, let's do it.
Well, yes, please. Yeah, I
Yeah,
know that. Yeah,
yeah.
yeah, absolutely.
So.
Yeah, that makes perfect sense.
Well, cool, Matt. This was great. This was a great first start at the live stream here. I hope
Yeah, yeah.
hope you
Nerve wracking,
enjoyed it.
but I think that was pretty cool. That was a lot of much enjoyed. You gotta say.
Yeah, we'll do some more, and I really appreciate it. And everybody that's listening, if you have things for us to touch on next time, you want us to talk about a specific topic, put it in the comments, and we'll
Yeah.
take a look at all those.
Yeah, 100%. And if you're interested in the Exo games, the submission for the TPUs is coming up, where myself and Bill will be judges on the actual event. And yeah, it should be cool. Should be cool.
Should be a great time.
Yeah,
We always learn something from the Exo Games. It's a great event, so definitely
yeah, it really
recommend
is.
that to any students and universities out there.
Yeah, absolutely. Well, have a